Hello, this is Leader Squirrel, and this time of class we're going to do Let's Discuss of page 185, and this is lesson 3 of chapter 6. So let's get started. So let's discuss. Let's begin with what is prime factorization. I know I'm doing this awkwardly. Well, in the book it first introduced about factor tree, but I'm going to introduce about prime factorization first. Well, prime factorization is breaking down or disassemble a composite number to a prime factor. It is talking about the overall process. And let's see, if the composite number is made by a prime factor multiplied by prime factor multiplied by a composite number, oh, there's a SPY, composite number, then the prime factorization is not completed. But, well, it is going on. So this is the process is called prime factorization, making a composite number to the process making to only consist of prime multiplications of prime factors. And in the book it introduced a way of factor tree. Factor tree is doing a prime factorization by doing in these kind of forms. So let's look at more closely about what is factor tree and prime factorization. Let's see, for example, which number should I try? I know, well, there's already answers in the book, but let's try, okay, let's try a number, that'll be, okay, 18th. Let's try 48. Okay, 48. So this is a composite number. Okay, I'm gonna just write it down as CN, composite number. So let's first divide this 48 to 2. So there is 2, and if we divide it 48 to 2, that would be 24. And 2 is already a prime factor, but 24 is a composite number. So what do I do with composite number? You do the process again. So first you divide it with 2 again, as this is an even number, and the number comes out as 12, and 12 is a prime factor, but 12 is still a composite number. So 12, what you do again, you divide with a prime factor again, which is, this time I'm going to try 3, and 3 is a prime factor. This is PF, prime factor, this is all PF, prime factor. So 3 is a prime factor, and the number divided, that is the quotient of dividing 12 with 3, is 4. And 4 looks like prime factor, but not. This is a composite number. And you know the drill. 4, if you divide it with 2, and the quotient would be 2. And these are all prime factors. This is all prime factors. So what do you do with them? Well, you can just sack all the prime factor, and 48 is equal to, there is 2, okay, there are 2, and 2 multiplied 2, and here's 3, and you multiply 3, and there's 2 multiplied 2, and there's 2 multiplied by 2. So this is going to be 2 multiplied 2 is 4, 4 multiplied 3 is 12, and 12 multiplied 2 is 24, and 24 multiplied 2 is 48. And yes, it consists only a multiplication of prime factors. And this process of making a number to a multiplication of with only prime factors is called a prime factorization. Prime factorization. This is a process. So even if the process ends here, it is a prime factorization, but the prime factorization is not over. But if you do until here and make it to a number here, the prime factorization is over and completely done. So that is what the shape or the process of doing prime factorization in this form, in this way, in this particular way, is called factor tree. And making a number with this process to making to only composite of prime factor is prime factorization. So in the way of prime factorization, you don't need to do with the factor tree. Well, you can simply, for example, even let's say I'm going to do with the not the obvious one. Let's try, what number should we try? Let's try 36. Is there 36 here? Nope. 36. And you can just do, divide, and, okay, let's do it this way. If you divide, this is going to be 18, right? And if you divide 2 again, and it'll gonna be, let's say 9. And if you divide, okay, not equal, by the way. If you divide with 2 again, then no, you cannot divide with 2 this time. If you divide with, this is not equal, this is just an arrow. Please remember that. Divide with 3, this is going to be 3. And if you divide with 3 again, this is going to be 1. And prime factorization is finished. 36 consists of 2 here, multiplied by 2 here, multiplied by 3 here, 3 this 3, and multiply another 3, this 3. And this is going to be, 2 multiplied 2 is 4, 3 multiplied 3 is 9, and 4 multiplied 9 is 36. So without factor tree, I just done a prime factorization. So sorry, this is 36, by the way. So yeah, this is what is called prime factorization. And let's try it with, lastly, with the factor tree. What number should I try? Let's see, I want to try a big number, a really big and aggressive number. 210. I'm going to try 210. And actually there's a reason with this. But with the prime factorization, I'm going to try to make it I'm going to do a prime factorization using a process of factor tree. Let's divide with 2. And 2, this would be 105. Now let's try it with 3. If I divide it with 3, this becomes 35. Let's divide with 5. It's going to be 5, and 35 is a multiplication of 3 multiplied by 7. So if I sack all of this number, the final version of prime factorization is 210 is equal to 2 multiplied by 3 multiplied by 5 multiplied by 7. And this would be 2 multiplied by 3 is 6, and 5 multiplied by 7 is 35. And if you multiply this, let's see in the long way. You multiply with this is going to be 30, this is going to be 18, and if you do a plus, this would be 0, 11, 1 over here, and 1 plus 1 is 210. Amazing. So this is what is called a prime factorization. And try the examples here. The answer is going to be pretty much the same. So this is what is factor tree, and the process is called prime factorization. So thanks for watching, and see ya in Let's Try.